Section 4.4, trigonometric functions of any angle. So we're kind of breaking off of those predetermined values from the unit circle and looking at any ordered pair x comma y and what the 6 trigonometric values of that angle would be. So any point in the coordinate plane with coordinates x comma y, x the horizontal distance, y the vertical distance, r our radius value, you can find that with some good old Pythagorean theorem. So if the r value is not given to you, you can find that. So when we go to set up our trig values, okay, what we can do is we can use the x's and y's just like we did back in section 4.2, but now instead of that radius always being 1, it's going to be an r value. So sine instead of y over 1 is y over r. Cosine instead of x over 1 is x over r. Tangent doesn't change, y over x. And then we look at the reciprocals. Cotangent is x over y. Secant is r over x. Cosecant is r over y. Okay, so when you're looking at trigonometric functions of any angle, any ordered pair x comma y, you now have to utilize that radius value. And remember, these x's and y's, they could be positive or negative. R is always positive. R is a distance from the origin out to the point. Because you're doing Pythagorean theorem, it's going to be a positive value. So just some things to remember here, okay, is that when you are in a specific quadrant, x and y could be positive or negative, some combination of that. So when you start looking at sine, cosine, and tangent, which are dependent on your x and y values, sine, cosine, tangent could be positive or negative depending on where you are. Now in the first quadrant, it's pretty straightforward. Everything is positive. X and y are both positive, so sine, cosine, and tangent are all going to be positive as well. You can expect that to happen if you're ever in the first quadrant. In the second quadrant, though, x is now negative. So anything involving x will be negative. So cosine and tangent. Sine will still be positive because in the second quadrant, y is still positive. In the third quadrant, both x and y are negative. So sine, which involves y, is negative. Cosine, which involves x, is negative. Tangent involves both of them. Negative over a negative gives you a positive. In quadrant 4, our y values are negative, so sine is going to be negative. X is positive, so cosine is positive. But then tangent will be negative because you have a negative y over a positive x value. So for these problems, I think it's very helpful to draw a picture, okay? I even have it right there. It may be helpful to draw a picture. The point -3, 4. So we are in the second quadrant, 3 units over, 4 units up. So we're looking at this angle right here, that theta value. Now, the beauty of reference angles is that we can use them to represent the angle we're actually trying to find. So we're actually finding theta right here, okay? But we're going to use theta prime, theta with a little dash, reference angle, okay? Because that reference angle will then set up our reference right triangle. We have our x value of -3, our y value of +4, and Pythagorean triple. It's almost like I wrote this to be a Pythagorean triple, okay? Radius is going to be 5. So when I go to find sine of theta, I'm using a reference angle theta prime to create a reference triangle, but it'll still be the obtuse angle because the x value is negative. So sine y over r, 4 over 5, cosine x over r, -3 over 5, tangent y over x, 4 over -3. Draw the picture, label your information, just take it step by step. You won't have a problem at all.